Hello everyone, let's talk about verifying trigonometric identities. The objective here is to manipulate the left-hand side and right-hand side of both sides of the trig equation until both sides agree. Always remember your basic trigonometric identities, the relationship of the basic trig functions, making equivalent fractions, using conjugates, and how to do algebraic manipulations. There is no one way to do these kinds of trig functions, identities, questions. We can work from one side to get the result of the other. For example, we can work from the left-hand side to get to the right-hand side, or we can work from the right-hand side to get to the left-hand side, the result of the left-hand side. Or we can work with both sides at the same time until we get to some common solution in the middle. Let's look at some examples. Verify that secant theta minus cosine theta is equal to sine theta times tan theta. Now let's start using the left-hand side. The general idea is that we don't necessarily have to pick any one side, but in general, we like to deal with a side that looks more complicated or the one that we can manipulate. So we start with secant theta minus cosine theta is E. And let us rewrite our secant theta minus cosine theta. Rewrite our secant theta as 1 over cosine theta. And then write our cosine theta as cosine theta over 1. Cosine theta over 1. Right. Okay, now we're going to use our ideas of equivalent fractions to make a common denominator for this. So if we multiply the left side by the denominator of the right side, which was times 1 over 1, and multiply the right side by the denominator of the left side, which is cosine theta over cosine theta, right? And this will become 1 over cosine theta minus cosine squared theta over cosine theta. So that's going to be the same denominator there. And then what do we know about cosine squared theta, or 1 minus cosine squared theta? If you recall from the Pythagorean theorem, Pythagorean identity, that 1 minus cosine squared theta is the same as sine squared theta, right? Then you can just plug that in. Otherwise, you can replace this one with sine squared theta plus cosine squared theta. But we know that this is just sine squared theta, so they make it sine squared theta over cosine theta. And then sine squared theta over cosine theta, because we're trying to get to this side. Let's break the sine squared theta into sine theta times sine of theta over cosine theta. And then this part, sine theta over cosine theta, is the same as tan theta. So we arrive at our right-hand side, which is sine theta, tan theta, and so this is our right-hand side. Okay, and we are done. Once we get to the expression on the right-hand side, we are done. Let's verify that cosine theta over 1 minus sine theta is 1 plus sine theta over cosine theta. Again, let's start with our left-hand side, which is cosine theta over 1 minus sine theta, and do some manipulations to try to get to the right-hand side. What we can do with this cosine theta over 1 minus sine theta is just to multiply by the conjugate. Let's do it by the conjugate of the denominator. And so let's just multiply by 1 plus sine theta over 1 plus sine theta. And let's see what we end up with. So we have now cosine theta times 1 plus sine theta all over, this becomes the difference of squared 1 minus sine squared theta. Right, so that's over 1 minus sine squared theta. But 1 minus sine squared theta is the same as cos squared theta. So end up with cos theta 1 plus sine theta over cos squared theta. And if we divide cos theta into cos squared theta, we end up with 1 over cos theta, which now becomes the equivalent of our right-hand side, which is 1 plus sine theta at the top over cos theta at the bottom, and then that is our right-hand side. 1 plus sine theta at the top, because cosine theta cancels out cosine squared theta, the denominator. So we're left with 1 over cos theta. 1 times 1 plus sine theta is 1 plus sine theta, and then over cosine theta. Okay, verify the equation. John is an identity. Cosine of negative x, tan of negative x over sine of x equals negative 1. Cosine of negative x, we know that cos is an even function. So because cos is an even function, then cosine of negative x will become the cosine of x. So cosine of x times tan of negative x over sine of x. And then tan of negative x, we can write that as the negative tan of x. We want to do that, right? It's negative tan of x. So that's cosine of x times negative tan of x over sine of x. All right, because tan is odd function. Okay, then we're going to continue doing some more stuff. Cosine of x. Tan of x is the same as cosine of x, or sine of x over cosine of x. Right. Don't forget your negative sign, all that over sine of x. So now we know that there's a cosine here. Cosine of x we can write as cosine of x over 1. And so this cosine of x will cancel this cosine of x down the bottom. And so this becomes negative sine of x over sine of x. And that's equal to negative 1, and that's your right-hand side. And we're done. Okay, verify the equation is an identity. 1 over 1 minus cosine of x minus 1 over 1 plus cosine of x. And then from that, we can use our ideas again of conjugates to use the conjugate idea. Just try to make equivalent fractions. Or common denominator idea. And so let's multiply both sides by the denominator of the other side. So multiply left side by 1 minus cos x over 1 minus cos x, and multiply the left side by 1 plus cos x over 1 plus cos x. And so this will become 1 plus cos x. Then what will be in the denominator is 1 minus cos squared x. And then this will be minus 1 minus cos x at the top, right? 1 minus plus x at the top. Let's continue simplifying these and see what happened. We distribute this negative through, we can end up with 1 plus cos x minus 1 plus cos x over 1 minus cos squared x is the same as sine squared x. And then this 1 minus this 1 goes, so we end up with 2 cos x over sine squared x. Okay, let's see where we're going. So cos x, sine squared x is the same as sine x over sine x. So let's break this into 2 cos x over sine x over sine x. Let's break this the different parts. 2 cos x over sine x times sine x. Cos x over sine x is the same as cotan x. So this becomes 2 cotan of x. 1 over sine x gives you cosecant x. And this is our right hand side. And we're done. About trig substitution. The objective here is to plug one trig expression for x and then simplify the entire expression. So basically we need to get a trig expression and know what the identities should be for a particular trig expression, and then we can just plug in and simplify. So example, let's write x squared plus 9, radical x squared plus 9 as a function of theta, where theta is between 0 and pi over 2, making the substitution x is equal to 3 tan theta. So wherever you see x, you will put in 3 tan theta. So this will be x squared will be 3 tan theta squared. Right. And plus 9. Let's continue working algebra here. This becomes radical of 9. 3 squared is 9. Tan squared theta plus 9. Then from this expression under the radical, we can factor out 9. So we end up with radical 9 tan squared theta plus 1. And so, you know that tan squared theta plus 1 is the same as secant squared theta. Secant squared theta is 9 secant squared theta. We take the square root of 9, that's going to be 3. Square root of secant squared theta will just be secant theta. And we're done, right? So this fits the interval that we have been given. Okay, the next substitution we have to make is radical a squared minus x squared. It's a function of theta where radicals made the substitution x is equal to a sine theta. And for theta between negative pi over 2 to pi over 2. So plug in x is equal to a sine theta, so that's a squared minus a sine theta squared. And so that's going to be a squared minus a squared sine squared theta. And so that's, if we factor out the a squared, we end up with a squared 1 minus sine squared theta. It's a radical sine. 1 minus sine squared theta is the same as cos squared theta. It's going to be a squared cos squared theta. And so finally, take the positive root, that's going to be a cos theta as our final answer. And this is true because of the restrictions given in the question. Thanks for watching. See you next lesson.